So like, but it's just like doing like delta math and stuff like that. Not when I'm like teaching. Okay. Okay, let's see here. Cohort B. Still got all right. Let's go ahead and check some of you guys off here. So Jesse, oh, over here. Jesse's here. And let's see, Anaya. Okay, so Jesse and Anaya. Matthew. Okay, Matthew. So Jesse, Anaya, Matthew. Okay. Reese. How's it going, Reese? Oh, good. Good. Hannah. Okay. Let's see. Aiden Sylvie. Okay. And you go by Aiden, right? Yeah. Yeah, they still have that have a different name on here, so. Yeah, I don't know why. Yeah, weird. Okay. Okay, and then Evelyn. Right. Okay. And Ariana. Okay. And Judith. Judith is not here. And Seth. It's not here. Okay. So nice to meet you guys in person. That's awesome. I'm gonna do my very best to learn all your names. You have the math to learn, and I have your names to learn. So I always like to make sure that I know everyone's names and all that. So do my very best. So try to mix things up and get all of that out. So Jesse, Evelyn, Reese, Matthew, Aiden in the back, and then Anaya. Mhm. I have to, it'll take me a little while. Okay. Name again? What's your name again? Yes. Hannah and Ariana. Okay, Hannah and Ariana. I will remember your names. I promise. I just have to figure out. I just gotta get the names to the faces now. So it is so great to see you guys in person, though. Really happy that you guys are here. I hope you stick around. Like I said, it's I agree. It's nice being here and not being at home all the time. It's nice to get out and be somewhere else, be around other people. I'm really enjoying it so far. So glad you're here. Looking forward to our time together. And again, we have our portal, everyone at home. So glad that you're joining us as well. Hello, everyone. Actually, I think I'm on this camera here. Let me just go ahead and switch the camera over. Make sure that we're looking at the right thing. There we go. Why is it printed down so far? That's better. Okay, there we go. So now, hello everyone at home. So that camera there is usually what people at home are going to be seeing. So when you're at home watching me teach or whatever, that's the camera that I'm using right there. That one or this one. And then, yeah. All right, how are you guys doing at home? Doing okay? Hello out there. This is why it's so great that you guys are here in person, right? I mean, so much more interactive. Oh, hey, yes, I got a hi. Doing good. Awesome. Thanks, Charlie, Anthony, Bryant. Glad you're out there. Thanks for checking in. All right. Let's go ahead and get started here. All right, so last time we were talking about the Pythagorean theorem, and we're going to continue today with a little bit more of the Pythagorean theorem. We're going to do some word problems today, but we're still using that same equation, the same formula from last time, working with the Pythagorean theorem. So let's go ahead and just start off by just a quick review. What is the Pythagorean theorem equation? What are we using here? Yeah, what is it? Yes. Hannah, right? Yes. Practice. So a squared plus b squared equals c squared. So we got a squared plus b squared equals c squared. And so we're going to be using that equation again today. Just we'll use it with some word problems and a little more complicated problems. So try to step things up a little bit. All right, so let's start by looking at some examples. All right, we've already done notes on the Pythagorean theorem itself. Go. All right, so let's take a look at something like this. Oh yes, this will be a good one to start with. Actually, almost feel like I want to start with one a little simpler than that. A little simpler than that. Not that simple. Not that simple. We'll get to a nice, good example here in a second. Oh, come on. Yeah, all right, we'll do this. Okay. Now let's do this on a new page. Let's go ahead and cut that, paste. There we go. Now we have more room and you can see it better. Okay, so we want to find the length of the third side. This is just like what we did last time, right? The difference, really the only difference with what we're doing now is instead of rounding to the nearest tenth, we're writing our answer in simplest radical form. Okay, which means we're going to have to be simplifying some radicals. But the first part of the problem is going to be pretty much the same, right? We want to find the length of the third side, which is this one right here. I'll put an X on that one so that we use that variable in our equation. And then we want to write out our equation. So go ahead and try writing an equation for this. What would our equation be? Plug everything in. What do you get for your equation? Okay, 4 squared plus b squared equals 7 squared. What do you guys think? Agree or disagree? Agree? Okay. Yeah, that definitely works. We can do that. We get Ariana, right?
Yes.
Okay. Thank you. Okay, and you can use b or x, whatever variable you want to go ahead and use. Since you put b there, we'll go ahead and change. Oops. Didn't mean to do that. There we go. Back. Let me lock that so it doesn't get erased again. Let me change this to just b. All right, so we got 4b and 7. We're going to try to find 4 squared plus b squared is equal to 7 squared, and we're going to go ahead and solve this. So, what next? Yeah, go ahead, Maria.
So 4 squared, so 4 times 4 is 2.
Uh-huh.
Plus b squared.
Okay. Very good. And Hannah, you want to take it from there? $33? Oh, well, that's kind of a boring answer. Not your fault, though. I mean, it's the problem, right? 33. Darn. Okay, that's fine. So hoping for something a little more exciting than that. All right. B squared equals 33. Now what? Yeah, so now we do the square root part. All right, we're going to do the square root of both sides. And I don't know if you guys see why this is boring. Take the square root of both sides. We're going to get b is equal to the square root of 33. Now, we're not going to do this as a decimal this time, right? Remember last time we put that in our calculator, rounded to 10. We're not going to do that this time. We want to keep our answer as a radical in simplest radical form. So this is where we would simplify. Can you simplify the square root of 33? No. Which is why this is boring. We're supposed to simplify, and square root of 33 cannot be simplified. So that's just your answer. It's easy, but it's also boring. It's like, okay, cool. The answer is square root of 33. You guys know why it doesn't simplify? I mean, should I go over that?
Yeah.
Explain that a little bit? Okay. Remember that when we are simplifying radicals, we need to factor the number inside the square root. The way that you can either do that with a factor tree, or the way that I do it is I break it into 2 square roots. Right, I do like square root of 33 is equal to, two different square roots. But what are the factors of 33? 3, 11 and 3. And that's it. Both of those are prime. So this is the only way to factor 33. 11 times 3. Is the square root of, can we simplify the square root of 11? Is that a whole number? No. What about the square root of 3? Also not a whole number. So that tells me that we cannot simplify this. This is the only way to factor 33. And we can't simplify either of those. So we're done. It's just the answer is the square root of 33. Kind of boring, but oh well. I was hoping for one where we actually had to simplify. Now, if you wanted to know what that is as a decimal, you would just punch that in your calculator and get it. For this one, you would have to put the square root only because they specifically ask you to write it in simplest radical form. So some of these problems will ask you to round to the nearest tenth. If it says that, it means that they want a decimal. And if it says write in simplest radical form, it means that they do not want a decimal. They want it as a square root or a whole number, right? If it's like the square root of 16, you can simplify that down to 4. But otherwise, you would just leave it as a square root like this. So, all right, I really need to get a more interesting example here, though. That's so what's that? That was a square root of 33. Oh, hey, I like this one. This one we get to talk about something else, kind of interesting. I like this. This is actually what I was looking for in the first place. Find the length of the third side. If necessary, write in simplest radical form. Right. So our third side is down here. That's our x. What looks different about this problem here? Yeah, it already has a square root on both sides there. That's a little different. Feel. Yeah, I like that one. 25353. Yeah, 352535. Try that. Okay, got it solved yet? Just kidding. But yeah, anybody get it started though? Try writing an equation maybe?
Yeah.
So you put a squared plus 7 squared equals what? Yep. A squared plus 7 squared equals the square root of 74 squared. So we've got our two legs, right? Maybe I should we'll do that as A, right? That's our first leg, our other leg, and the hypotenuse. And yeah, we square all of those, right? So all of those need to be squared. Put an A here. And I wanted to go over this because I specifically want to talk about the hypotenuse, square root of 74 squared with you guys. So A squared, that's normal. 7 squared, we know how to do that. What's 7 squared? What is it?
49.
49. Get Ariana. And then we have the square root of 74 squared. What do you think that is? Yeah. This is just 74. Square root of 74 squared, 74. What's that?
Why would how would it equal 7?
To answer that, let's pick like an easier number. Let's say it was like the square root of 9 squared. What's the square root of 9? And what's 3 squared? So when you do the square root of 9, you get 3. And then when you square that, you get 9. It kind of like, it's like you're doing the square root, but then you're squaring it again. It undoes itself. You know? Same thing is going to happen here, except when you do the square root of 74, you're going to get this really crazy decimal. But then when you square that decimal, you get 74. So when you square a square root, they're just going to cancel out, and you're left with the number that's inside the square root. So I just want you to see that because you will see problems like this where you need to square a square root, and you need to know that those cancel out, leaving you with just the number inside. So if you have to do that, square root of 74 squared is just 74. From here, we can move forward as usual. Somebody else. Our next step here. Okay, what do we subtract?
49.
Okay, so we're going to subtract 49. So we get a squared is equal to, what is it? 25? Okay. Square root. Square root of a squared and square root of 25. Yeah. By the way, here, when we're doing the square root of a squared, that's a lot like what we did up here with the square root of 74 squared, how they cancel out. Same thing is happening here. Do the square root of a squared, that's just a. Very similar situation. And that's equal to 5. So this side down here, that was weird. This would be 5. questions on that one there? Everyone at home, how you guys doing? Following along with this, okay? Okay. Let's see. I think. That should be good with that one. Yes, the answer there would just be 5. Submit, yes. Good to go. What is that? Okay. What about these ones? It's the exact same problem. That should simplify. I feel like we should do at least one where we have to simplify, and then we'll do some work problems. Go ahead and try this one. See how far you can get on this one here. Try writing your equation and then solving the equation. It should not be a whole number. Pretty sure. Okay, but we also don't want it to be a decimal, because if you look at the instructions, it says write the answer in simplest radical form. So we want to write our answer in simplest radical form. So if you got 7.2, it's possible that that is correct, but we want to get that in simplest radical form and not a decimal. So what was your square root? Square root of what? Okay, that's interesting. Got something. What did you get? Square root of 85? Anybody else get the same thing or something different? I think 85 sounds a little big. I think it's a little small, a little less than that. So then what you want to do is once you get that number, you want to factor that. Try to factor that into numbers that you can simplify, or at least one that you can simplify. Do you have an equation that you started with? Four squared plus b squared equals 6 squared. Okay, so you're on the right track. 6 is not the hypotenuse though. Yes, so C, the hypotenuse is going to be, oh, that's a highlighter. We want the hypotenuse to be this one over here. How do we know that that's the hypotenuse? Yeah, so if you look at the right angle, do you see how the right angle looks like an arrow? It's like, okay, that arrow is going to point to the hypotenuse always. So this arrow here is pointing at the C. So this is going to be your hypotenuse. So yeah, so very good. We should have 4 squared plus 6 squared is equal to C squared. Okay, and then we simplify this a little bit. Jesse, to get that simplified?
I was kind of confused on this.
Okay.
I got it.
Let's take a second, see if you can do the next, figure out the next step. I want to simplify these numbers here. Like, what's 4 squared? 4 times 4. Put that there. Plus, what's 6 squared? 6 times 6. Help it. What's 6 squared? 36. Guess we got 16 plus 36 is equal to C squared. And then we can combine those numbers together. What do we get there? 52. Okay. And that's at 90. I don't know where. Yeah, we're not going to use a 90. Yes, we're going to add these 16 plus 36, and that's 52. 52 is equal to C squared. And then we get to this part here, we're going to do what now? Square root, exactly. So square root of 52 and the square root of C squared. Now, this is where, instead of just putting your calculator and getting a decimal, we want to factor this. We want to factor the 52 and try to simplify it. Which we can do this. So did anybody figure out how to factor? Well, let's kind of, I guess, go through it together. What are some ways to factor 52? We'll do it over here. 52. What are some ways to factor 52? Obviously, there's 1 times 52. that doesn't really help us. What is it? 226? 4 and 13. 4 times 13 is 52, yeah. And I think that's probably it. Yeah, I think those are all. Now, out of all these numbers, there's only one number in this list that we can simplify square root of. Yeah, what is it, Ariane? It's a 4. Square root of 4. So we want to use this. We're going to write this as c is equal to the square root of 4 times the square root of 13, right? We're going to break that up into 2 square roots, square root of 4 and square root of 13. And then we can simplify the first one. Square root of 4 can be simplified. What do we get when we do that? 2 and then the square root of 13. Exactly. Square root of 13, we do not simplify the square root of 13. Let's leave that one alone. Square root of 4 we simplify, and that's 2. That's right. Over here we would write 2 square root 13. Okay. Does that answer your question, Brian? That's simplifying the radical. We should probably talk about some word problems here, and then, or do you guys want to like take a little break, just work on some of the homework here? Try these ones out. Try these ones out for a minute. Yeah. That'll give me a chance to catch my breath. All right, so check out homework 21 for a few minutes, and then we'll do some word problems after that. So in Delta Math, if you log into Delta Math, it's homework 21. The first couple parts of homework 21 are these kind of problems here, where you need to just find the third side and write the answer in the simplest radical form. Let's go ahead and try that out. Maybe we'll do that for like 10 minutes. If you guys have any questions, let me know. I can do like an example, another example, or do one of the problems with you guys. And if you're at home right now, you can just do the same thing. Take a minute to look at Delta Math homework. Try some of those first parts. And let me know if you have any questions. I'll put you guys in like breakout rooms so you can work together if you need to, or if you'd like to. go over a couple of word problems with you guys, just to see how they're doing. Most of them are hopefully pretty straightforward. Once you see an example, you'll understand how to work through the problems. They all have to do with the Pythagorean theorem, so you're still going to be using that equation. What I recommend is drawing a picture to model the situation. So in this problem here, because none of these problems will give you a picture, it's just the word problem, it's just the sentence. And geometry word problems, you almost always want to draw a picture. All right, so in this one, you start driving north. So these are driving word problems. You're going to basically drive in one direction, drive in another direction. So we're going to start driving north for 21 miles, turn right, and drive east for another 20 miles. At the end of driving, what is your straight line distance from your starting point? So we're going to draw a triangle. So let's say we start here. And what direction do we drive first? North. How far do we drive? How many miles? 21 miles. North. So we're going to drive north 21 miles. And then what do we do? We're going to turn right. And do what? We're going to go to the right 20 miles. We end up here. What do we want to know? What are we trying to find? Straight line distance from the starting point. So that's the distance from here to here. You want to know, what is this? And the 90-degree angle is going to be right here because we were going north and then we turned right. We started driving east. That's a 90-degree turn. So that's where our 90-degree angle is going to be. From here, we now have a picture. We're going to use the Pythagorean theorem, use the equation to find the straight line distance from the starting point. That's that black line that I drew. So this line right here, that's what we're trying to find. Maybe it's okay. You'll do great at these word problems. No worries. Maybe somebody at home haven't interacted with you guys a lot. So somebody out there at home, what equation would you write for this problem here? Okay, a squared plus b squared equals x squared, right? Let's plug in, what about if we plug in some numbers here? What are we going to plug in? You are correct. That's a good starting point, right? We're going to be doing, a squared plus b squared is equal to x. Don't forget the squared there. But we can plug in some numbers. So somebody else at home want to add to that? We have some specific numbers we can plug in to the equation. Yeah, very good. Thank you, Anthony and Bryant. All right, we got, Trinity, did you do first, 20? Yeah, 20 squared plus 21 squared is equal to x squared. Again, don't forget the square on the x. The x is being squared as well. Okay. And then we got some big numbers here, so probably use your calculator. I'll open it up to anybody, so you guys here as well. What's 20 squared? 400 plus 21 squared is 441. 441 is equal to x squared. Very good. So we're going to have 841 equal to x squared. Now out there at home, what do we do? What do we do with this? What's our next step? Somebody at home. We don't want to divide. There's something else that we do to get rid of the exponent. We want to get rid of the square here. So this is an important step. It's in all of them. Yeah, there you go, Bryant. We're going to do a square root. So technically, we're doing the square root of both sides. All right, so we want to do the square root of 841 and the square root of x squared. Square root of x squared is just x. And then, is that a whole number? 29? Okay, cool. X is equal to 29. So our answer, 29 miles, right? Talking about how far away are we from the starting point? So if you drive 21 miles north and then 20 miles east, you're only 29 miles away from where you started. It's interesting. I mean, you drove a lot farther than that, right? I mean, 21 miles plus 20 miles, that's 41 miles. So you drove 41 miles to get 29 miles away. But that's just, the nature of Pythagorean theorem, right? So, not too bad. So those are that's the driving ones. I put three different types of word problems on the homework here. This one was 29. Very good. Let's see. Ladder problems are definitely my favorite. I love ladder problems. Maybe because my dad is a painter and spent a lot of time like going up and down ladders, doing a lot of painting, stuff like that. So I've done a lot of that work. 34-foot ladder. That's a long ladder. That's a very tall ladder. I think you guys have climbed up really tall ladders and stuff. It's like, oh my goodness, it's getting really tall here. All right, so you got a 34-foot ladder against the top of a 30-foot tall building. How many feet will the bottom of the ladder be from the bottom of the building? Right? Because if you know anything about putting a ladder against a building, you need to move the base away from the building a little bit and lean it. Right? So the ladder is leaning against the building. And we want to know how far away from the building is the bottom of the ladder. Right, so the picture here that we're trying to draw, we get this on our whiteboard. The picture that we're trying to draw here is we're going to have we have a building, right? This tall building here. And then we have a ladder. Leaning against that building. Yes, Emirates. Amazing drawing. I'm an amazing artist. Here we go. Now it kind of looks like a ladder. All right, so we've got a ladder, we've got a building. We need to put some numbers on our picture though. So where do we put some of these numbers? Yeah. Well, so we want the numbers to represent the sides of the triangle, right? So we've got, let me maybe tell you kind of what your choices are here, right? We've got, does everybody see the triangle? We've got this side of the triangle, the yellow side. We've got the blue side of the triangle here. We've got the green side of the triangle here. Okay, so everybody see our triangle that we're working with here? So we need to put these numbers on either the yellow side, the blue side, or the green side. Make that blue a little thicker here. So, Kenny, you said put the 34 on the ladder because it's a 34-foot ladder, right? So the ladder itself is 34 feet. Yeah, and the building is 30 feet. So that's the blue part here. So we're going to put the 30. Very good, Jesse. We'll put the 30 on the building. And then what are we trying to find? Yeah, how many feet will the bottom of the ladder be from the bottom of the building? Well, there's the bottom of the ladder and the bottom of the building. We want to know that's the yellow side, right? So the yellow side is the bottom of the ladder from the bottom of the building. The blue side is the building. It's the 30-foot building. And the yellow side, that's the, sorry, not yellow, green, is the 34-foot ladder. That's the kind of picture that we're working with. We've got 34-foot ladder leaning against a 30-foot building, and we want to know how far away from the bottom of the building is the ladder. I'm gonna put an X down there just because I like to label all sides, even the unknown ones with variables. So you can use X, you can use A or B if you want, because it is a lathe. So I use either A or B, completely up to you. But I like to label all the sides, even unknown ones. So if we're trying to find the yellow side, I'm going to call it X. All right. What is our equation? Close. Yeah, so it, right? Because the hypotenuse is the longest side, and in this case, the longest side is the ladder. The ladder is going to be our longest side here. So we want to make sure that the 34 is the hypotenuse. The 90 degree angle here, I mean, they don't actually assume this. They don't tell you this, but we are assuming that this building is going straight up out off the ground. I mean, you know, this problem would not work if it was like the Leaning Tower of Pisa or something, where the building is clearly not at a 90 degree angle, then we couldn't do that. They should probably say in here that the 30-foot building is perpendicular to the ground or something like that. By the way, this also assumes that the ground is level and you're not like on a hill, right? If you had a building on a hill and then you try to put a ladder against it, that also kind of changes things. So there's a few assumptions here that they kind of leave out, but we'll just go with it. We'll assume that the ground is flat, that the building is going up at a 90 degree angle, and makes the problem a little bit easier for us. So those are some just baseline assumptions. Is that a ladder? Yes, that is. You can't tell my amazing artwork. Yes, that is a ladder. Okay, cool. So we're gonna do x squared plus 30 squared is equal to 34 squared. And if you used A or B, that's fine too. X squared plus 30 squared equals 34 squared. And we'll just kind of crunch the numbers there. So why don't you try going through that problem, see what you get. Hey. Yes. Okay. Ready to get the answer? Yeah. What did you get, Hannah? What did you get, Hannah? 16? Is that what you got? All right. Anybody else get there? Yet? Not yet?
I just added up the numbers.
Okay. Did you square them first? Did you like? Okay. It's like what was 30 squared? 900 equals 34 squared was
1,156.
56. Okay. And what do we do here?
Add them together.
Don't actually want to add them here. That's the yeah, because see how we got x squared plus 900 equals this? They're on different sides of the equation. We don't want to add. Well, we can't combine. What we can do is subtract 900 to move it to the other side. Yeah, and what's that?
It's 256.
256. Very good. We're going to get x squared is equal to 256. And then the next step is going to get us to the 16, you said, right? Yeah, very good. We're going to do the square root. So the square root of x squared, the square root of 256 is going to give us 16. So the ladder is 16 feet. 16 feet away from the building. Pretty tall. Maybe a little trickier than the driving ones, driving word problems. Any questions on that? Does that kind of make sense? Okay. Again, the picture is really is a valuable part of this. So it's an important part of this. So I highly recommend draw the picture. If you have highlighters, you can highlight the different parts of the triangle if that helps you. And then look for those parts in the word problem. Like the ladder is 34 feet, the building is 30 feet. And then we want to find the distance from the bottom of the ladder to the bottom of the building. So you can try to find those pieces of information in the word problem. All right. I think this is just one more type of word problem here. That one's 16. That's the TV word problem. So you've probably seen this with TVs, they do it with computers, tablets, all that stuff. They'll say, this tablet has a 10.4-inch screen. Or, phone. They do it with phones, right? This phone has a however many inch screen. TV, 65-inch TV. What are they measuring? When they tell you that a TV is 65 inches, what are they measuring?
The bottom.
What part of the screen? Corner to corner. Yeah, they're actually measuring corner to corner TV screen. It's the same with phones, tablets, computers. Anytime they tell you the size of the screen, that measurement is actually the size of the screen corner to corner, diagonally. Top of one corner to the bottom of the opposite corner. So they're telling you a diagonal distance. Seriously? They need to certain television is advertised as a 5-inch TV. Are you kidding me? 5-inch TV? Let me watch that's yep, there's my TV. There. I wear my TV on my wrist. 5-inch TV. What? I feel like I need to just give us a different problem because nobody gets a 5-inch TV. That's just ridiculous. No. That's a little better. 45-inch TV. That's believable. Who would get a 5-inch TV? All right. A 45-inch TV. That's believable. Okay, a certain television is advertised as a 45-inch TV. That's the diagonal length, corner to corner diagonal. Now, if the width of the TV is 36 inches, how tall is the TV? What's that?
When you ask how tall it is,
Yeah. How tall is the TV? Top to bottom. Right? It's a 45. So we got a 45-inch TV. That doesn't mean it's 45 inches tall, right? It's 45 inches corner to corner. We want to know how tall it is. All right, so got our TV here. I don't know how to make it fancier than just a rectangle, sorry. Put like a stand or something on it. And we got a little stand on each side. All right. And then we want to figure out some information about this. Now, first of all, TVs are rectangles, not triangles. So you guys see the triangle? Yeah, so we're gonna go corner to corner. Now you guys see the triangle, right? Okay, so we draw that corner to draw that line from corner to corner. Now we can see that we do have a triangle.
wouldn't that be all the corners?
What's that?
Wouldn't that be all the other corner on top too?
Yeah, up here?
Yeah.
Yep. We could actually use either of these triangles. They're congruent triangles, just flipped around. So yes, we could actually use either one. Let's where do we put the numbers? Okay, good. So the 45 is going to go on the diagonal. So that's the diagonal length. Yeah, the bottom or the top. Yeah. Yeah, you could put it on. Let's just put it on both, I guess. All right, so we got the bottom and the top. That's the width, which is 36 inches. So that's either up here or down here. It's a rectangle. The top and the bottom are going to be the same. And then we've got the sides, which is how tall it is. Right? And that we don't. That's what we're trying to find. So I'll just put, X there. And then you can choose whichever triangle. I mean, it's same. It's gonna be the same whether you do the top triangle or the bottom one. Give that a shot. See if you can solve that. Which one's the hypotenuse, though? 45, good. So go ahead and try writing your equation. Make sure 45 is the hypotenuse.
So it would be A, and then it would be 36.
Yes. All of them squared. That would work. Very good. Okay, so kind of work through this step by step. What did you get, Hannah, for the 27? Okay, so we'll see if that's what we get. You got 27? Or
Wait, for like the whole total.
or something else. Yeah. What did you get?
Oh, no, that's the track.
Uh-huh.
I guess I would never even find out.
Mm-hmm. And then you just got one, and then you just have one more step. So you're on the right track there. Okay, so first when we do the 36 squared, what's that? 1,296 is equal to 45 squared. 125, okay. We'll be there in just a few years. Hopefully not wearing masks. X squared, okay, plus 1296 equals 2025. Okay. And that's the 729, okay. And then we're going to do the square root, and we get a whole number for this. And that is, what did you say, 27?
Yeah.
Okay, perfect. So the TV is 27 inches tall. So it's a 45-inch TV, but that doesn't mean that it's 45 inches tall. It's only 27 inches tall. 27 inches tall, 36 inches tall. So now you know a little bit about TV screens and phone screens, tablet screens, computer screens, all those screens. How they measure those, corner to corner. And 5-inch TVs. If you find one, let me know. I'd be very curious to see what do you do with a 5-inch TV. Oh my goodness, that's ridiculous. All right. All right, well, that's all the time we got for today, guys. Hopefully that helps. The homework for this is not due until, 'cause next week is spring break. So yeah, I won't see you guys again. So have a great spring break. For your time off. And then, this will be due like the Friday after we come back. So this will be due in like 2 weeks. You got some time. Plenty of time to work. Okay, and everybody at home, if I don't see you, have a great spring break. Enjoy your time off. Get some rest, have some fun. I'll see you guys when we get back.
All right, goodbye.
See you later. Bye, Brian.
See ya.
What are you guys up to next? French. History. Spanish. Okay. What do you have? History. A lot of history.
Yeah, I think we're in three class.
Oh, okay. Okay. Who's doing the history for PSA? Yeah, that's cool. I've taught. I was the math teacher for an academy once. Not here, another school. It was fun though. I like that. It was fun. It was a good experience. Yeah, like all the academy students.
Yeah.
Get to know them really well. It's fun.
How big is your TV?
I don't No, off the top of my head. It's fairly large.
Can't you do the math?
Yes, I just don't know the number off the top of my head. I don't have it memorized.
Yeah.
Yeah, okay.
One more month.
It's bigger than 5 inches.
I'm like, oh.
We got an 85.
Oh.
Mine is not that big.
Wow.
I think it's 60. Maybe. Might be like a 65 inch. Maybe. I'm not sure.
All right.
Have a great spring break. All right. Bye, everybody. See you later.
What's up, Bryant?
What's up?
I got that stuff done. I just haven't transferred it yet from classroom to, the grade book.
Oh, okay.
So just hang in there. We'll get there soon.
Okay.
You don't need to be on camera here. Bryant. Thank you. Oops. All right, Gilbert. Oh. What the? Got Nevaeh, Nicholas. Seth, I got. Marini. Angel Lopez. Joe. Desiree. Isabel. Elani. Luis. Dina. Salma. Ashley. Willow. Jasmine. Hi, who snuck in back here? Yeah. Carolina. Hi, Carolina. Good to see you. And you are 4B. So we'll walk around the classroom, see how 4B is right there. So I do the seating chart so we stay as distant as possible, socially distanced as possible. All right, we're gonna get going here in just a second. I got more people coming into class. We'll get them. Melissa. And Nicole. Vince. All right. Okay, so those of you who are cohort A's and were here the other day, you've heard this, but I'm going to go ahead and talk to the students that are here about some of our many rules. We got a lot of rules here. You guys like rules? You're gonna love this. I got lots of rules, so here they are. Okay. All right. Did you just slip in?
Yeah.
You know how I know? That's not a C. Who are you?
Ariana. Ariana.
Ariana, you are 11B. So here's my many rules. First of all, we will maintain our masks while we're in the classroom here. Okay. However, I'm adjusting to wearing a mask all day, as you guys will. This will be your first day of school, right? You guys are going to be adjusting to wearing this thing all day. If you feel like, God, I just got to take this thing off, that door generally will be open unless it gets really hot when I close it. But you can step outside, take your mask off, and breathe. Okay, come back in, go back to work. All right. So you have the freedom. You don't have to ask me to do it. Just step out. I understand. I got it. I understand. And I do the same thing myself. Okay. So that's one of my rules. Next, restroom. No passes. No, we're not shuffling paper. We're not passing paper. Okay, during our pandemic here. If you need to go to the restroom, simply raise your hand. Mr. Gack, can I go to the restroom? Yes, you may. And right down that walk, the closest is down the walk into the new buildings over there, right across. You may know where the restrooms are there, but that's the closest. Okay. The thing I ask about restroom is don't order around campus, don't meet friends, don't do that kind of stuff. If you've come a long time, then we'll discuss your restroom privileges. Okay. So that's restroom. Josh and Sherman. Okay, here's another one of my many rules. So there'll be days that we require a textbook in here. Underneath the pairs of desks, and if you'll notice, one desk is A, that's where the cohort A sit, and you guys are B's, that's where you guys sit. But there's a shared textbook under the desk. On days when we use it, you're gonna get it out, you're gonna do what we're gonna do with it. When we're done, we close it, we grab wipes. I got Lysol wipes there, and I got a big bucket of wipes there. And we wipe the front cover, back cover, and put it underneath the desk. Okay. At the end of the class, we take another wipe and we wipe off the top of our desks for the next class coming in. Okay. Let me think about it. I think that's the rules. A lot of them, aren't there? Aren't those a lot of rules? Okay. So that's it. All right. I told you guys, if you were on Zoom the other day, you heard this, but things aren't going to change a lot in here based on what we've been doing. How we do assignments, the kind of assignments, pretty much kind of the same stuff. Okay, the advantage you guys have that I've already found in Monday, Tuesday, and period 1 today is that those of you who are here are getting work done. Okay, and I've had some students, and you guys might fall in this category, some of you, who haven't been real steady getting assignments in. Your grade's not exactly what you want. If you dedicate to getting here And I think once you're here, you gotta focus and get this stuff done much better than you do at home, because at home you got a lot of distractions. You will find that you're gonna do this grade-wise, okay? You're gonna do that. So I would take advantage of these next 8 weeks. Be here, be steady, and once you're in class, you know, I monitor kind of what you do. I walk around, ask questions, see how you're doing, and people are getting stuff done. Okay, so I think that's the real advantage to being here, other than change of scenery, getting out of the house, seeing friends again, all of that's a big plus also. All right, okay. I left a message for you guys, or I told you anyway, to make sure you bring your notebook. So let's get the notebooks out. We started notes on Monday, and we're going to wrap them up here today. One of the things we do. Those of you at home, and we had a staff meeting yesterday, and the common complaint amongst at least the history teachers is the balancing act with us as teachers now, teaching to students here in the classroom and kind of not forgetting about you guys at home. All right. It's a completely different structure than we've ever had to do before. So send chats. I come and I check the chats. If you have any questions, things on your mind, whatever it might be, you know, make sure you write it down and I'll get to it. All right. So I'm going to share our notes here and we are going to get rolling.
kill their animals to avoid handing them over to the government.